Okay students, up to now we have been discussing about the model of an atom, the subatomic particles, and how they are arranged in an atom. Then we discussed how to write electronic configuration of atoms. And based on that we classified and divided atoms into the modern periodic table. Then you know how to identify the position of different elements in the periodic table based on their electronic configuration. Now we are going into a new topic, isotopes. The atoms with different mass numbers in the same element are known as isotopes of that element. But their atomic number, that is the number of protons, is equal. Example: hydrogen has 3 isotopes. They are called protium, deuterium, and tritium. So if we look at protium, it has atomic number 1. So protons 1. And electrons 1. The mass number is 1. So you all know mass number is protons plus neutrons. So here if protons is 1, then the neutrons should be 0. So if we look at deuterium, it has atomic number 1. So protons 1. And electrons 1. The mass number is 2. So you all know mass number is protons plus neutrons. So here if protons is 1, then the neutrons should also be 1. So if we look at tritium, it has atomic number 1. So protons 1. And electrons 1. The mass number is 3. So here if protons is 1, then the neutrons should be 2, so that it is equal to 3. So with this we'll finish the discussion on isotopes. Now we will see some patterns that are seen in the periodic table. When we discuss periodic table, I told you all that when elements are arranged into the periodic table, you will see similarities and patterns. In the periodic table it can be seen that the physical and chemical properties of the elements change according to a systematic pattern across a period from left to right and from top to bottom of a group. To study those patterns, let's consider the following properties of the elements. First, ionization energy. Electronegativity. The negatively charged electrons are attracted by the positively charged nucleus. So to remove an electron from an atom, energy must be supplied to overcome that attraction. When an electron is removed from an atom, it becomes a positive ion. The first ionization energy of an element is the minimum energy that should be supplied to an atom in the gaseous state to remove an electron to form a unipositive gaseous ion. The formation of a unipositive gaseous ion by removing an electron from an atom in the gaseous state can be represented by a chemical equation as follows. Na leaving an electron becomes Na+. So Na++ electron forms sodium solid. This energy is a comparatively small value for an atom. Therefore, this value is given for 6.022 into 10 to the power 23 atoms, or a mole of atoms. Accordingly, the first ionization energy of sodium is 495 kilojoules per mole. Likewise, it's calculated for all the elements. So from this figure you can see that the ionization increases from left to right across the period, and it decreases down the group. In a given period, the group 1 elements have the minimum first ionization energy. Also in every period, group 8 elements have the maximum ionization energy. From left to right in a period, the first ionization energy varies in a regular manner. Then here if we plot this in a graph, it will look like this. So you can see it's like zigzag. So now let's look about electronegativity. Electronegativity means the ability of an atom of an element to attract the electrons of a bond towards itself when it is bonded to an atom of another element. More about electronegativity will be discussed under the unit on chemical bonds. There are several scales to quantify the electronegativity, of which the Pauling scale has been adopted here. As per the Pauling scale, fluorine is considered the element of highest electronegativity. Pauling scale does not assign electronegativity values to noble gases because noble gases show less tendency to form chemical bonds. it can be seen that the electronegativity increases from left to right across a period. It is also seen that, down a group, electronegativity decreases. In this too we have a zigzag pattern. And we have come to the end of our video. Let's discuss the other parts in the next video. So please give a support to us by subscribing to MI Academy, and also please, like my videos, and add up your questions and doubts in the comments. I will try to reply them as soon as possible. Share the videos with your friends, and help them to learn, quickly and easily. Pattern seen in the periodic.